Yeah. Um, Hi, thank you. My name is Remy Rojas. I'm working as a software engineer at Exoscale. I've been working at Exoscale for around 3 years, and over a year ago, I sort of took over and became a full-time responsible, or my responsibility became full-time to manage our managed Kubernetes offering called SKS. So today I wanted to talk about a little bit of how it works. We're gonna. So the agenda is to first we have a we are a sponsor here at KCD, so we have a mandatory marketing pitch at the beginning. I'll try to be brief with this, but you might still be interested in seeing it if you've never heard of us. Then I will explain what SKS is from a product perspective, so from a customer looking to use SKS and what advantages that it come with. And then we will take the more engineering approach and look at SKS's architecture. So we will look at how the sausage is made. We're going to look at internals, sort of which components is SKS made of, but also like in what SKS is doing under the hood. Then we will look at a concrete scenario, creating a cluster for a customer. We will see how different parts of our infrastructure interact with others. I think it's quite interesting, and it gives a good viewpoint or a good perspective on what is running where, which is very interesting to see the interactions that are going there, and you can really have a good perspective of what's going on. Then we will look at some challenges that we have currently and the solutions we're thinking about. And finally, some exciting, at least to me, upcoming changes that we're going to implement in the near future. TM. Right. So, what is Exoscale? We are a cloud provider. As you can see, we have 6 zones. Zagreb will be launched in a couple weeks, fingers crossed. And we do everything from bottom to top. So we are mounting the racks on the data centers. Some of them we rent, some of them we are provided by our mother company, A1 Digital. And we do all of that, all the way to the JavaScript running on your browser when you go to the portal. So fair to say it's a full stack. So Exoscale is a platform. It's an infrastructure as a service, but we also offer managed services. So the infrastructure part comprises your typical compute stuff like instances, instance pool, NLB, private networks, and GPU. I was reminded to say this. We are now offering liquid-cooled GPUs, which is it's nice. It's in our latest blog post. Go check it out. On the managed services side, we have S3 compatible object storage. We have block storage, so you can attach volumes to your Kubernetes clusters or your instances. We have database as a service, which is pretty self-explanatory. We have IAM, our own flavor of IAM, which I used to develop in the past, which is pretty nice because I did it. And what we're gonna do, or what we're gonna talk today about, is SKS, the managed Kubernetes offering. So, SKS stands for Scalable Kubernetes Service. And the objective of this product is to abstract away the burden of managing a Kubernetes cluster. So you are a customer, you come to us, and you do not want or know how to handle Kubernetes in let's say, operational way. You just want to run your workload. You found some fancy YAML file that you want to apply on a Kubernetes cluster, and you don't want to deal with anything else. This is fine. However, let's start by defining what a Kubernetes cluster is. And here we are at KCD, so I guess everyone has a pretty good idea of what a cluster is. For me, what I'm interested in today is to see what is the minimum, sort of the bare bones thing or set of things that you can still call a cluster. Right, so we have an API server, we have a controller manager, a scheduler. We often call this a control plane. These are just processes running on some runtime, and you can already consider this a cluster. And for me, at least, and if you give it some resources, some memory, some CPU, some IPs, then you can allow it to run some workloads, and this is what happens in real life, right? The cluster part for me is those three main processes that I mentioned before, and all of the rest is like what's on top, what's being managed by the Kubernetes cluster. So, what do we mean by managing? This is the things that, as I mentioned, a customer will come to us and use our API for. So we are abstracting this away from the customer. So the lifecycle of a cluster, to begin with, create, update, delete, but also handle upgrade. So if you want to upgrade from Cube 129 to 133, we have a path to do that, and it's a click of a button, right? We don't want people to need to mess with this. We provide the infrastructure naturally, since we provide instances. We automate the provisioning of node pools. So the nodes, you start an instance pool, and if you do it from SKS, the underlying instance will be provisioned in such a way that kubelet is ready to join your cluster. So when you start the instance, it just knows where to go and knows what to do, and boom, you have a node pool. Add-on lifecycle. So we provide a set of add-ons, sort of to have a more batteries included experience for our users. We provide custom CNIs, Calico and Cilium. I think they're the biggest on the market. Cilium is probably the more interesting proposition right now. We have our own cloud controller manager that will talk to the platform on your behalf. It will do nice things such as deploy a load balancer when you want to expose some service. And we have a container storage interface that will interact with our block storage solution, so you can directly hook up volumes to your containers and your workloads. And finally, some functionality, which is some nice to have. Generating kube configs, that one's pretty simple. Providing PKI, so you have access to the CAs so that you can make your own certificates if you really need to. And rotating credentials, because some of the add-ons, they need credentials to talk to the platform. And well, you can sometimes mess those up, or maybe you think you had someone get into your stuff and you need to rotate those. So it's there. So we do this for you. You don't need to fiddle with which secret do I have to change now, and do I have to restart the deployment or whatever now. We do it for you. Right. So what's the typical user experience? It's all behind our clients. This is the CLI, but we also have a Terraform provider. In this case, I'm creating a cluster. I give it a zone. I specify I want a CNI. I specify the service level. The service level is just how many control plane nodes will be running. If you choose Pro, you will have high availability on those. Sorry, not nodes, but containers. You will have high availability, API server and scheduler, and a bunch of others. I don't remember the exact list right now. We give it a node pool, the size of our node pool, and the security group that the node pool will be using. Right. So this is all we need. We wait a minute or two. We have a it returns. It actually is asynchronous, but we keep polling behind the scenes. Then we get a kubeconfig, and we are able to do kube control. So it's from 0 to kube control in basically 2 steps, which is pretty nice and kind of responds to the previous slide. It's what we want users to experience, and this is what I mean by managing or abstracting. Anyway, that's for the product part. Now let's talk about the architecture a little bit. So, as I mentioned before, we have a bunch of zones, and in each zone we have a huge platform cluster. So it's a Kubernetes cluster that runs our internal workloads, and SKS just happens to be another one of those workloads that we have in-house, basically. So SKS is a stateful set. We have a bunch of, so it's high availability. It serves user and machine requests, and it does so asynchronously. And most of its state is stored in a database. So the database has a bunch of functions, or it stores a different kind of data. So it stores data about the state of the resources, the state of your clusters, what if they are running, updating, deleting, upgrading, and such. It stores the configuration of your clusters, whether you have add-ons, which version are your add-ons on, and it also stores workflows. Workflows are simply the units of work that SKS will do, and it will a workflow is composed of different tasks, and SKS will go pick a task, execute it, and report back to the database that, hey, I finished this task. In case something or someone kills me, the next pod can take over. So we expose SKS through a service, and we have a bunch of cron jobs that will do some job for fault recovery, upgrade propagation, and maintenance. So the upgrade propagation work is because SKS will basically respond to requests, but it will not necessarily know if there is, for example, a new template version of a node pool, or if there is a new version of Calico being made available. And so we need these cron jobs to sort of verify what would be the desired state, and update it in the database so that SKS can then go pick it up and work on it. Right. So in a typical request from a user, the user will tell SKS to do something. SKS will save the desired state of the world in the database. It will tell the user, okay, I have a request, I heard you. Here is an operation ID. You can pull it if you want. This is what it tells actually the CLI. And here's your resource ID in case you forgot, or in case I just created it for you. Afterwards comes the reconciliation. And this is the kind of asynchronous part, where SKS will look at a task and go, oh, maybe I need to go and create some nodes, or delete some nodes, or update the user data in those nodes. Maybe I need to create some credentials for this add-on that we don't have yet, or I need to delete it, or I need to rotate it. Maybe I need to create some workloads on the platform cluster because I have a kube client and I can do that. Or maybe I need access to the customer cluster because not all of the stuff we deploy lives on our own platform. Sometimes we will deploy stuff on your infrastructure that you buy from us. And it's interesting to think or to realize, and this is sort of foreshadowing, that the user can also see what's going on with their resources when SKS is basically managing them. So as a user, you might notice that when you're, for example, a credential is rotated, that you will have a new IAM key, but also that for some reason your add-on is restarting. So there's a new pod for your add-on. That's not a coincidence. And sort of the trade-off for the user is that, well, we don't give you a cluster and let you out in the dark. We sort of keep managing it while you're using it to some degree, but we try to be as unobtrusive as possible. And we will see why this is sometimes, not everyone agrees with this, and sometimes it's a problem, but it's an interesting point of discussion, I think, to understand where the trade-off is. So let's look at how we create a cluster. So in my previous slide, we will just look at, it's basically what's going on here, right? So the first thing that SKS does is it contacts a local etcd cluster. For those who don't know, etcd is the state store for Kubernetes. It will store the state of a cluster. And it tells, hey, there's going to be a new role and a new user for this. So create that, please. Then it's going to talk to the platform cluster. It's going to say, okay, hey, create some deployments. I need some deployments in this SKS namespace because it's probably going to be the control plane for your cluster, your customer cluster. So now the customer cluster is launched, and we configure the API server to go talk to this etcd cluster. So now this new API server that's running inside the platform cluster is talking to a bespoke etcd cluster, so it's not registering with the same one as we're using. So we're doing Kubernetes inside Kubernetes, essentially. And the only detail here, and this is why I thought it was important to mention at the beginning what is a cluster, is that this is already a cluster. You might disagree with me, but the only difference with the cluster you have at home is that this one cannot schedule workloads because it doesn't have anywhere to. You cannot schedule workloads on our platform cluster because it's our infrastructure, it's not yours, right? If you want to schedule workloads, you need to talk to the instance pool service, and you need to ask instance pool, or rather you need to make a node pool, which in practical terms means telling SKS, hey, instance pool, please make a node pool for me. So it will do. And it just so happens that the user data that we start those instances with is configured to talk to your control plane. So now your workloads will start popping up. You get a kube. So at this point, you can already get a kube config. You'll get a kube config. You'll do kube control get pods, and you will see all of your pods. They will just not be running because there's nowhere to schedule them. Now your pods are running. Now they're starting to be deployed. And so this brings us to what I think is the core of my talk, and what I want you to remember from this talk is that I had this. I thought about this little analogy yesterday when I was having trouble sleeping because I was nervous about this talk, and also it was raining and thunder, so I couldn't sleep anyway. So it gave me time to think, and I think, so I live in Prague, right? And in Prague, we have a big problem with landlords and rent. So I thought, like, well, we are the landlord, right? Exoscale is the landlord in this case. So there are some things imagine we're offering apartments, and maybe we don't want our tenants to touch the boiler or to touch the fuses because we are engineers and we think we know better, and or we are someone in management and we think we know better, and we are afraid we will mess it up, and maybe it's easier that we, the owners, will manage these things for you. You will pay us a little price because it's running on our, like, let's call it room. But on the other hand, now you don't need to have the space for the boiler because it's not in your apartment, right? It's not in your infrastructure. Also, you don't have to maintain it. If there are problems with it, it's our responsibility. It's not yours. Also, you get a stove, which uses the gas connection, for example. Or you get a fridge, which uses the electricity, a shower. And these things, maybe you can tweak with, but it's still sort of ours. Because the day we find there was a gas leak in the stove, we will change it, and we will not ask you permission to change it, right? Because we manage it. That's sort of the contract. So even if you see it, even if it's in your house, even if it's in your apartment, it's still like managed by us. So you get to tell us what do you want, but you don't really today you don't really get to tell us how, and you don't get to modify it after the fact. So this counts only for the add-ons and like the utilities that we deploy so that your cluster can work. But in a more general sense, sometimes you're deploying something and the configuration doesn't match or whatever, and the typical example is core DNS. So you'll change the DNS configuration to something that suits you, and then we're not happy with it because something breaks on our side. So we get to detect that and we get to override it. And then you open a support ticket, and then we have a funny conversation that we've had many times. Right. So I hope you see the trade-off here of doing this instead of us just giving you everything or selling you a house, let's say. And basically it's up to you if you want to take it or not, right? So how much time I have left? I have 10 minutes, perfect. So one of the current challenges we have, as you might have guessed, is having a shared etcd cluster. So this etcd cluster is shared by basically many customers on a typical zone. On the biggest ones, we have like 150 clusters running at once. At this point, we already have several etcd clusters deployed because at the beginning, it's nice. It's very simple maintenance and deployment, and it gives you a good bang for your buck. However, it just takes one noisy neighbor to, crash the party for everyone, right? If etcd stops responding for a certain amount of time, let's say a couple seconds, API server panics. It stops working. It goes like, no, it cannot save its state. It's like, no, I'm not doing this. So we started running into scalability issues, which was sort of expected. So nowadays we are. So yeah, this is also the problem, that when you request it too much, it's not so much the request, it's more about the compacting and fragmentation that happens afterwards. etcd cannot work as long as you're defragmenting a disk. And so what we're doing now is we are deploying. First of all, we're like offloading. We're making more etcd clusters, and eventually we will probably move into dedicated etcd clusters for the big guys. I guess, though, we will be charging for that. Yeah, it impacts uptime. Great slides. So this is what I was alluding before with my little analogy. So, we see the same things, right? And from the SKS point of view, we try to be as less intrusive as possible. We don't look into your cluster. We don't want to know what are you doing in your cluster. That's not our business. We just want to, when we have when we detect a vulnerability or when we update, we have a meaningful update to a component that's running on your cluster. I'm sorry, here's the update. So it brings up the question of who owns what, and maybe we're crushing your bespoke configuration. Should we perform reparation when your component is actually something we just want to give it to you and we don't care anymore what you do with it? And it becomes kind of a tug of war between like, I own this, no, I own this, but it's running on my stuff, but so it's a difficult line to thread, and we hope to get better. One way to do this is with an upcoming change. We want to introduce a compatibility matrix. So this right now we have a one-on-one relationship between the version of the component that's deployed. Let's take the example of Cilium, and the Kubernetes version you're running. So we would like to have a world where, or a product where you get to choose out of supported versions of certain components, and we tell you, okay, this is good enough. You don't need to change Cilium to have the new Kubernetes, or vice versa. You don't need to change Kubernetes to have a new Cilium. And this allows us also to open up, tiers of version tiers like alpha, beta, and stuff like this. So this can be really nice, and it's not that far into the future. And finally, a more technical thing. Right now, SKS is dealing with all of the deployment, so we're calling the apply API command on Kubernetes directly from SKS. And sometimes it's unclear whether we want this to be. It's a lot of work and logic that could be offloaded onto a more Kubernetes way, let's call it. So to have an operator, and to this extent, we're looking into. This is very bleeding edge, right? We're not fully committed to this yet, but I thought it was interesting to bring up that, for example, we're looking at Sveltos, which is kind of a fleet manager in Kubernetes. So you give it a bunch of clusters and you tell it, okay, these clusters have these tags, and then you have profiles. And profiles basically let you deploy different things, resources into Kubernetes, and whenever your cluster responds to this profile, it will be applied on your cluster. And this is pretty nice and a good development. And we pass from just dumbly applying, manifest after manifest, and rather we say, okay, this we manage tags. Now we say, okay, this tag, this cluster has this amount of tags, and we have, on the other hand, profiles that match or not the tags that we have on a cluster. Another nice thing is it helps us to thread the line a little bit more easily between here's a microwave, do whatever you want with it. So this is the fire and forget. Here's a microwave, like not our problem anymore. And we really don't want you to touch this. So please don't touch your shower. If you touch your shower and you tweak the water temperature or something, we will come and fix it. Or Mr. Sveltos will come and fix it for you, right? And there's nothing you can do about it. So that's my talk. Thank you for being here. Thank you for your time. And I think we are just on time, and we have time for questions.
Yeah.
Thank you.
Thank you. Okay, we already have a few questions up there.
Okay. I don't know exactly what's meant by Kubernetes distribution. Whoever asked that, can you explain a little bit? Maybe I'm not too familiar with the term.
Well, if it's some vanilla Kubernetes or some.
Yeah, it's pretty vanilla Kubernetes. We're deploying it ourselves. Yeah. Do you throttle kube API calls somehow, or do you deny to access some parts of it? If yes, the metrics 4.4 to 9 available. No, but we could. It's a good point. We could.
Yeah, other clouds do this, but they give the metrics so we can see if we are.
If you are, yeah, sort of like Docker does when you start pulling too much and you start having the use case for your own registry, right?
You can suffer from it, by the way, but they give metrics so you can see when it happens, you do something bad.
Yeah, that's a good point. Thank you. So how are you dealing with API-intensive workload, like Kubernetes clusters running large cross-plane instances, primarily managing API objects? Well, I mentioned we have high availability for our control plane if you choose the Pro package. So this should be fine, and you actually have also autoscaler for those deployments. So autoscaler, the response here I think is mostly autoscaler takes care of it, and if then we have to, if we have to do instances, we will just schedule all of this because it's asynchronous. We don't really suffer from that much. I hope that answers the question. Okay, sure. When upgrading a cluster, do you check for deprecations in customer clusters? What do you do when customers doesn't want to upgrade? It's deprecated workload. It's up to the customer to upgrade. Usually we try to, right now we take the Kube version as sort of the holy grail, right? Our point of reference is the Kube Kubernetes version that you're running. And so if you don't upgrade that, it's very unlikely that we will deploy something that is incompatible with it. That would be a mistake on our side. However, you might have components that you run yourself that are not compatible with the new Cilium version, let's say, that we are deploying. Today, unfortunately, we will just do it. And we will communicate that we are doing it, but we will not ask most of the time, right? Because it's a configuration that's not set in stone, but that is uniform across the fleet. So usually, if you are fine with the Kubernetes version, if whatever you're running is also like tracking that, you're good. It shouldn't be a problem. And yeah, you have auto upgrade if you want. So you can either tell us like, okay, there's a new patch version, please upgrade me immediately, or no, I like this patch version. We have customers that are still on 120, 121 Kubernetes. We don't like to talk about it, but it's true. How do you handle upgrades of stuff that impacts pods, like CRI, client's control plane, etc.? That's a good question. So usually, of pods, impacts pods. Well,
if you upgrade like if you run containerd, when you upgrade the version,
right.
Impacts the pods.
Right. So the underlying, more like infrastructure upgrades.
Yeah, basically.
So we have we build our own node template, and you will get the template that's we have a template for every Kubernetes version. And if we notice that we need to update something in that template, we will probably tell you about it, but I'm not sure if we actually send an email for this. I would have to double check. But nothing will happen to your workloads until you cycle your nodes. So the new nodes will start with the new instance pool, but the old nodes will stay on the previous one. So that way, we are not forcing you to like redistribute the pods around, right?
Thank you.
Sure. And I think that's it, and we are
That's all.
right on time. Nice.
Yeah, perfect. Thank you very much.
All right. Thank you.